Okay.
There you go.
Thank you. So then, since this is being recorded, so I will post the recorded one. If whoever is missing the class, you can watch it again. But if you need to have interaction, if you need to have any questions and get the answers to the group works questions or the homework questions, anything that you concern, you have to really be here right on the time and ask your questions. Okay, so I have changed actually the class time to be half an hour earlier. Is not really because of the class time. It's just really, if you have any question, ask me before 11, then we can use the class time as usual for teaching. Okay, so it's just really question answer for half an hour before the class, and then I will start right at 11 to teach, and then I'll use the class time to teach, and we just go regularly the way that we have done for the last 8 weeks. And then the speed is really slower, which is fine for us, as long as we can just cover whatever we can. That's just perfect. So the school says we have to keep teaching, so there is no way to just stop teaching or say the classes are canceled. No, they are not canceled. It's just really going on, and we have to teach at the same time. And as I said, when we are doing online, we are saving a lot of time. So because we don't have to drive, we are staying at home, is really at least 1 hour and a half, maybe more, saving is staying at home. So we can use that time for question answer. As I said, I have started the meeting half an hour earlier for question answers. And that's including your group work, including your assignments or any lectures that you have. If you want to watch the other types of video that I have posted, so that gives you a lot of examples. There are many, many examples in that video, just plus whatever we try during the Zoom. So for all of these lectures, there are 2 types of videos. You can watch the videos which is on YouTube, the one which is just on the Zoom when I'm teaching, okay? So either or, you don't have to watch both of them. Any question?
No, I noticed that the recording the week or last class was no longer available on Zoom. It seems to have. Oh my
God!
It seemed to
that's
have
keeping
left.
it temporary, huh?
Yeah, my other professor said there was something about scheduled that allowed it to be. I don't know ins and outs of it or whatever, but yeah, it was. I think it was up for like maybe 2 days, and before I clicked on the link again, and it didn't. It didn't. It took me.
Everyone else has the same problem?
I downloaded it, so if anybody needs it, I can.
Oh yeah, that's what I want to say. Okay, so
download it.
Please keep it some. I think I mentioned in one of the emails. Please keep it somewhere because we don't know how much space they have. Obviously, they don't have that much space to keep all of them, and that's not the good news for us. So what I've done is I tried to make a YouTube channel and keep them on the YouTube channel. Okay, so but I've done for the last 3 classes that I've made, and it's just for now it's public. So I mean, if you just search my name, you can just see which section is yours and then which one is just for. Please make sure I'm recording. We don't want to miss that recording thing. Okay. So then for now I have saved for mine, but since I didn't have that much space to keep, so then I put it in the YouTube channel. That was just for my solution, just really for now, because I don't know, Peter, how much space do you have to save every single one?
Me?
You don't know, right?
I have about 8 terabytes of hard drive space. So.
Okay, so then yeah, whoever has enough space can download and keep it. If you don't have it, for me the solution was just to put it on YouTube and make it public. But I'm just kind of scary for now to leave it on. What is public, because it's just really me and you, and we are talking about something. If it's just really something personal, we don't want to share with everyone else. So these are the concerns that I have to make them public, and I don't know that much about YouTube to just make it private. So that's just something that I need to find out. But for now, if you search something similar, my name or Calculus 3 something, you can just get that videos on the YouTube channel under my name. but it's really basic. You have to make sure your class is section 7. You have started at 11 a.m. That was just the date that we have done the class. So this is the information that you need to show.
If you're concerned about privacy, I can just host a Google Drive and share the link with everybody in class.
I think that would be a good idea. If you have anything that can help me and your classmates, just do it, okay? So that would be a good idea. However you're sharing with them, so you keep the privacy for them. This is just because every student in this class has a right to keep that videos, to download that videos and to keep it. So it's not about our class. So we are fine with our class, okay? Sylvia, if you have any question about the homeworks, or everyone, if you have any question about the homeworks, you must ask me half an hour before the class or half an hour after the class time, okay? So remember, we are available from 10:30. So to make sure I answer your questions before the class meeting, and then we will be available after the class for a few minutes. I don't know, however you have any question about anything, you must ask me in before the class time or after the class time, okay? So if you have any question, I'm hearing you have a question, and that's just great to ask your questions, but at least be here a little bit before the class time. And I made it open for half an hour earlier, and then we were just really free. And then same for what is after class time. I'm running out the battery, so let me shut my phone. If I can just keep the camera on, that would be good, but it seems I don't have enough battery for my phone. Okay. And then I don't see my picture. How is my picture? Is it down too much? Question, guys. Is there any question?
I don't quite understand the midpoint rule that we might have gone over last week. So you take the midpoint of the x, like of the x and also the y?
Yes, yes. So
Okay.
if I can just really say, you have the rectangle region right over here, and then you have made it to this many pieces. So if you have the midpoint, so means you have to just go from here to here, right? So that's just the distance and made it half. And then you go from here to here and you made it half. Yes, it's just really both ways. So you have xi, which is the midpoint. So you have to have end point minus the start point divided by 2. Or you can just say add divide by 2, that still gives you the average. And for y, you can just say end point minus the start point divide by 2, and then you have, or you add it. So it's just really giving the same point. So then you have xi and yi. That's your midpoint.
Okay.
Any other question?
Nope.
Any other question?
It seems like a lot of people were having homework number 8, problem number 9. I don't exactly remember the exact.
It's the rectangle one. Like I wrote it so many times. I think I memorized the numbers. All right, so.
I have received an email about it, and as I said, if you can let me teach right now and then answer your questions after lecture time, okay? So because if people are going to leave, right, another class is starting or something like that. So I will answer every single question that you have about homework and group work really right after the class or before the class. So since, as I said, people are different schedule, I have no idea what the other professors or the other campus or the other colleges are doing. So just on the time that we must be available is just the class time. Let's just do the lecture, but it doesn't mean I don't answer your questions. So I will answer the questions. I'll try to do it really with the numbers because I got the email too, right after the class or before the class time. Okay, so if I couldn't answer right after class, so for some reason you have to leave, Sylvia, so I will answer before the next class. Okay, or I just do it and then record it and then you can have it, right? I think if everyone has same problem, it should be technical problem, which I don't have any really access or anything to fix. Because Brandon emailed me too, but I think it could be just technical problem if everyone has the same problem. Okay.
All right, no problem.
Are we good?
Yep.
To move on?
Yes, we can
Okay,
move
so this is my what is it? The new section of double integration. Just to remind you what we have learned from last class, let's just have what is just the warm-up problem. What's the process to do in double integration? We just say if you are going from 1 to 2 and then you're going from the 0 to 2 of some function, just e to the xy, and then you want to do it in terms of maybe yx to the, in terms of x and then in terms of the y. So what you need to do is just really start like order of operation, start from the inside and then you go outside. So you take the integration in terms of the x. So then it's just really e to the ax dx, which is going to be e to the ax divided by a. So that is e to the xy divided by constant, because I'm taking the integration in terms of the x. So y is my constant. And then I have had another y over there. So this is the inner one. I have to keep the outer one as it is. And then I have to plug in the values of the x because it was just the limits of the x to be from 0 to 2. So then I will evaluate this piece. So that gives me e to the x is 2y minus x is 0 times y. And then I integrate in terms of the y, which is just really doing what we have done in calculus 1. So one more time, same formula that I have had over there. So it's just 2y divided by 2. And then e to the 0 is just 1. Integration of 1 is y. And then I integrate. I've done my integration. So I just plug in my values. And then whatever is just upper limit minus lower limit, I can just get the value. So this is just when you have these things numbers constant. So basically when we say rectangular region, rectangular means these are all constant. Okay, so it means you are integrating over all numbers. So then you don't have any problem when you plug in here. This is just the numbers and everything is numbers. So that's perfect. But not all of our region is going to be numbers, or all of the region is going to be rectangular, or square, or lines. So that's why we have right over here the general region. So we call it general region, but I don't think that much is just that much general, because it's really limited things that we can do. So there are 2 different types of that general region. So as you see for the first one, you have done 2 of them to be constant, but one more thing that we call it general means one of them to be constant. Okay, so what do I mean by one of them to be constant? So either your x are really numbers, as you see their x's are the numbers, so then it's fine to have the y to be, curves, right? So this is what we call type 1 region. So type 1 region is the one that you have x's to be lines, x's to be constant. So this is all the x's to be between 2 lines, and the y value are not constants, because as I'm moving along the y-axis, is not really hitting any line. It's just really like this curvy shape at the beginning and this curvy shape at the end point. Okay, so as you see, the limits of constant always that has to be first, right? Always you have to write the constant limit must be first. Why the constant limit must be first? Because you want to, you're, as I said, there is no indefinite integration. At the end, all of us must get a number, right? So you have to get the result of this as a volume of something. So that is going to be a number, not the variable. So the first thing that we have to set always has, so now the order matter, right? So we have to start from whatever is a constant, and that should be number one. And then whatever left is just is the inside one, so which is your dy. Okay, so for this one, for this type of thing, as I said, I must start from the lines. These are my lines. And then for writing the inner one or the second one, you have to always make such these arrows. That helps you to say what is my lower limit is the one that is the bottom. And then what is my upper limit is the one which is on the top. Is it always clear like this problem? No, it's not always. So that's why I'm just encouraging you, please make that leader arrow that says which one hits first, which one hits next. Then you know which one is the lower limit, which one is upper limit. So the type one is the one that x is constant, y is two curves. And very similar to that one is just type 2. So what's happening in type 2, this time the y's are numbers, the y's are constant. If the y's is constant, you must start writing with this one. So my y is numbers is the first one. So then as you see in the graph, this should be two lines. This should be two lines in y direction, but x is just really a curve, right? So when x is a curve means I'm just really having this x as a variable, but since I have started from this constant, then the answer, the result at the end is going to be a number, right? So this is most important thing. You can't put the variables in the first limits, because then at the end you will have variables, which that doesn't make sense here, because we are finding the volume. Volume must be always a number, not a variable. And then for the finding the limit, for finding the limit of the x, always make this little arrow. You say, okay, I have just the way that the x is increasing is from left to the right. The way that x is increasing is from the left to the right. So I am moving from left to the right. So first thing that I hit is going to be my lower, and the last thing that I hit is going to be my upper limit. Okay, so same thing. If I'm moving from left to the right, left is the lower, right is the upper. So then that's just what you need. Okay, so always for what we call general region, at least one of them must be constant. Do I have always this type of things? No, you might have something that's just really general, like this one is really general. So then you have to somehow make it to the pieces and find out what is the smallest value and then biggest value. So not all regions can be right as type 1 and type 2. And if not, you have to break it down to the pieces, which can be written at type 1 and type 2. Does it make sense? Any question?
No.
Any? Move on?
Yes.
Okay, so the first example, it says which way you want to do type 1 or type 2. So that's just really, for most of problems that we have, it's possible to do in both ways. We will do whatever is easier to integrate, huh? So, but you can't see the limits of integration if you don't graph it, right? So you need to know how to graph. If you graph, then you see what's the limits of integration, right? So there is no way to guess where these two are intersecting, or what is the constants that I'm looking for, or which one is x's constant, so which is type 1, or y's is constant or type 2, unless you see the graph. So then it's essential really to see the graph, at least for double integration in just two-dimensional region, which was really what we learned in calculus 1 or algebra classes. But in triple integration, we needed 3 dimensions thing that we have learned in this course. Okay, so if I want to see whether it's type 1 or type 2, I I need to set the limits of integration to decide which one is just dx dy or dy dx. So then I just go to the algebra and try to graph it. So again, the roughly graph would be really enough. And the only thing is I need my intersections, okay? So this is y equals 2x squared. This is y equals 1 plus x squared. And then intersection of these two curves is going to be, what is it? 1 equals x squared. So then x is plus minus 1. So intersection is this one. Then I remember from algebra, these are both parabolas, right? So one of them is just 2. One of them is y equals 2x. And then the other one is y equals 1 plus x squared. I have shifted a little bit, what is it, 1 unit high, because that's 1 plus, and that's a parabola. As you see, I made it a little bit wider. That was just really something that we have learned in algebra. If you have twice of something, that is tighter. If it's half of that, is just the black one is just y equals 2x squared, and then I forgot 2x squared, and the green one is just 1 plus x squared. And then it was just really clear what's the intersection. So this is intersection from -1 to the 1. So basically this is going to be the region of integration, right? So this is going to be the region of integration. And then that's just what we by here was just really algebra, right, to graph them. Now you need to know, okay, is it type 1 or is type 2? Which one is the start point? Which one is the start point?
Type 1.
Type 1 means you have started, you have decided to make it the x's to be constant. Yes, that makes sense, because your minimum value and the maximum value clearly is between two numbers. So that means you have decided to make from -1 to the 1, and that is going to be the x's. So the lowest or the smallest value of the x to the biggest value of the x. And I don't think we have any problem with seeing this one is going to be the lowest one, and this one is going to be the biggest one for the x's, okay? And then the next term is going to be, let me just have some room for this one. So this is going to be dx. And then the next term is the dy. So now you want to write the dy. For the dy, as I said, you are writing for the y, okay? And that means you have to walk exactly along the y-axis, because the limits goes for the y, you are walking along the y-axis. So you are walking along the y-axis. The first is going to be your lower limit. The last is going to be your upper limit. So for this one, my black one is the first one, so it's 2x squared. And then the upper one is 1 plus x squared. Again, if you don't have a nice graph, it's not easy to see for this one, at least, and for many of these, which one is the lower, which one is the upper one. So you have to have a nice graph, at least for the intersections, okay? So to see which one is your limits of integration. If this is just really one problem in the test, if you write it by here, you will get really 80% of the credit, right? So what I'm trying to say, set the limits of integration in this course is the main job that you need to do. After that, for in the integration, I don't think you have any problem. It's just really going by steps, start from inner one and go outside, okay? So if you can set the limits of integration, you are almost done. Does it make sense?
Yeah. Are we always going from, we're always going to go from lower to upper?
Yes.
And I'm assuming if we're flipped along the x-axis, we're going to be going from left to right?
Always, exactly.
Okay. Good.
Do I need to just learn the other way that I have learned in calculus 1, or just switch it and then multiply by negative? No, we just always go in right way, then we don't have to worry about that negative sign. What I'm talking about, if you remember in calculus 1, that rule still is fine to use it, but this is just, we don't need to go this way. It's just really if you switch the limits of integration for some reason, so you have to multiply by a negative, right? A to B is the same as B to A. If you multiply by negative, That's true rule. It works here, but we don't need it. We go always from right way, which is lower to upper, left to the right. Make sense?
Yeah, thanks.
Any other question, guys? And it seems for this one that makes sense, right? So for this one is really easy to do in this way because actually it's just really either one is fine, right? Because it's really two separate function. Why either one is fine? Because this is just really all in terms of x, this is all in terms of the y. So you can just really separately integrate them, and there's not product rule, nothing to do with the integration by parts. It's just really easily integrate with respect to the x first. So sorry, y first. So I keep the last one as it is, and then I start to integrate in terms of the y. So that would be 2x. The sine is going to be cosine negative. Am I right? Sine is going to be cosine negative. Integration of sine is cosine negative. And then I have to plug in 2x squared for the y, and then 1 plus x squared for the y. Okay. So that gives me okay, minus 2x cosine of upper limit minus, and then minus to minus is 2x, and that's just cosine of lower limit, and that is just 2x squared. Okay. And this is going to be next term, dx. You are doing in terms of the dx. So let me just save some room for myself. I was too big. So that was 2x squared, and then now is the dx. Okay. So I don't think we have any problem right after this step, because that's just really another u substitution, and we know how to do it. This is a single integration, and we have done many of those in calculus 1 and calculus 2. So we just need to do the u substitution in a quick way. Okay, you don't need to change the limits of integration exactly. So in a quick way means don't change the limits as much as you can. If you like, do it, but I don't recommend you. Okay. And then don't change the limit, and then do your u substitution all the way here. You don't need to plug in or just do it separately and bring it here. So for example, if I call this one u, so the derivative is going to be 2x dx. Okay. So for this one is really clear. If I call this one u, this turns to be minus exactly cosine of the u, right? So that's just the du. This is going to be the du, and this is my u. So then it's going to be minus cosine of the u, and that's it, right? So then I know how to integrate such a this thing. So I can just integrate it, and then it's just saying this is minus sine of u, and then u is 1 plus x squared. Okay. So what I'm going to just ask you, and then practice, please do these steps all in your mind. I mean, practice to do all of this thing all in your mind, and keep this one for me. So for me, the next step is just really directly to write the answer is minus sine of, oops, sorry, I shouldn't write the integration because I did already the integration. So the answer was really minus sine of 1 plus x squared, and then you plug in from -1 to the 1. Okay. And same thing for the other one. I don't need to see all the steps, and then I'm just encouraging you, skip this kind of a step that is just really doable in your mind. So if you call u to be 2x squared, so then this time the du is going to be 4x dx, right? So then I have this one to be the du, and this one to be how much of the du? Can you tell me? It's half of the du, is that? So this is going to be half of whatever it is, because that was just 4x, and this is 2x. So it's just half of the du, and then integration of the cosine is going to be sine, sine of u, which is 2x squared, from -1 to the 1. So the steps that you are integrating in or you're doing U substitution is what you need to practice to skip it, okay? Because that's just something that you can do in your mind. If you like to write the steps, it's fine, but I'm just encouraging you and practice during the teaching to save your time when I'm just doing this type of U substitution. And after all, it's just really plugging the numbers of 1, which is 2, minus, again, minus 1, negative 1 to the 1 is 2, so that would be 0. And same thing over here, since it's just 2 times of 1 square minus, then 2 times of negative 1 square, and that's just all cancel out. So this by this cancel out, this by this cancel out, your answer or your result is going to be 0. Any question about any of these steps? Any question about any of these steps? Steven, Steven, are you listening?
Yes, I'm here.
So a funny question. When you do such this stuff, where does it save?
Where does the the OneNote saves to the cloud? Microsoft has Microsoft has their cloud drive. They call it the OneDrive, and so if you log in with your Microsoft account online, you can see where all of these notes end up saving. But
So
once you exit full screen mode, you can actually print this whole page to PDF,
oh, okay.
and you could upload it.
Okay, so because that was one of my problem, I shouldn't use this way, but it seems because I have used exactly 3 different accounts of Microsoft over here. One is just the personal one, 2 of them is from 2 different schools that I'm teaching, and it's just really messed up. I don't know which one goes, so that's just my mistake.
Yeah. This one, once you exit full screen mode, in the upper right hand corner of the screen, you'll have 3 dots that is your menu, and that will give you a drop down that says print and settings, and you can print it to PDF and choose where that PDF saves,
Okay.
and then you can upload it to you can upload it to Titanium, or you could print the physical copy out.
Excuse me. Any question? So this is a live, right? So we have to make the lecture with the kids at home. Okay. So if you don't have any question, we can move on to the next example. So maybe the good question would be, do you think you can set this example in what we call type 2? So is it possible to consider these are constants? So let's just make it highlighted. So is it possible to say this is just going to be a constant? So this is going to be a constant. So I'm just really moving from 0 all the way to the 2. And then if I'm just moving along the x-axis, if I'm moving along the x-axis, do I have really a nice limits of integration? It seems no, right? So do you see what's the problem? Do you see what's the problem? So this is just really different right from here. So right from here, you are getting different limits of integration. Down there, you have started from here all the way to here. And then up there, you have 2 different pieces, one here and one here. So basically, if you like to do it in that way, you really have to make it in 1, 2, 3 different pieces and 3 times of integration. So that's not a good idea. Is it possible? Yes, but it's just really tough. We don't like it, right? So this is the next example. Do I need to know for the examples like double integration to graph it in three-dimensional? No, you don't have to graph it in three-dimensional for double integration, but for triple, yes. For double integral, what you need to know is really two-dimensional, because that is giving you the region of integration, not the solid itself, right? Solid itself is your integrand, okay? So one more time to remind you, what we are trying to find is just really volume. And then if I'm just finding the volume, this is a double integration of some surface, right? So that surface is just really whatever you have it in terms of the z. So this is your surface. So this is, as we know, z as a function of xy is going to be the z or your surface or whatever is your integrand. And then for limits of integration, there should be something else somewhere else, right? So for limits of integration, it says this is the region of the in xy plane bounded between this line and this line, okay? So what I need to set the limits of integration, whether it's dx dy or dy dx, is not really in this surface, because that's my integrand. So what I have to graph is just my two-dimensional graph, or two lines or two curves, however is given to me, to see what's the limits of integration. And that's, as I said, is 80% of your job. Make sense? Ready?
Yep.
Okay. D is going to be between 2x and x squared. So you set them equal. So then you have x squared equals 2x. So this is x squared minus 2x equals 0, and then x factor out. And that gives me two solutions of x equals 0 and x equals 2. So these are your intersection. Why I'm finding the intersection first? Because that's just make my graph easier. I know which part of my graph I need to make it more clear or bigger, right? So since it's positive, means I don't need the negative piece of my graph. So just make it to be positive piece of my graph. And all of us know how to graph a line of y equals to x. So then I just make the x to be 1 and the y to be 2. So this is going to be number 1. I make it a different color because that gives me really nice upper lower limit. So this is the line of y equals 2x for me. And then the other one, since the intersection is at x equals 2, so I just keep going and make it x equals 2. So this is actually intersection point if I want to have a nice graph. So this is the other part of my parabola. I don't need to worry about the first part, because as I said, the intersection says is all the way here. So intersection says is all the way here, okay? So this is going to be what the region of integration is. And this is a kind of, I will say, nice problem. If I just erase, why it's erase an entire one? I was going to make my line of y to be bigger. So that is 4. That was 2 when I was plugging my numbers, yeah. And I said this is a very nice problem because, can you tell me, is it a type 1 region or type 2 region?
I would say type 1. You can go from 0 to 2 on your x-axis, yes?
Both.
Mm-hmm.
Both.
Any other idea?
I heard so both.
I heard both too. I was kind of thinking that because it looks like you can on both x and y. That's why.
So let's do both. All right. So we can do both. Yes. It's kind of when we have triangle form. Yes, that's true. You can do both. Okay. So let's just take care of type 1. Okay. So this is my type 1 version. So my type 1 version, as we said, we have to start with the x. So what is the limits of the x? What is the smallest value that you see in x? And what is the largest value you see in the x?
Smallest value would be 0.
So you'll go all the way from, yes?
0 to 2.
0 to 2. So we don't have any problem with this piece. So then I have the limits of the dy, which is always, okay, so remember making the little arrow, it's helpful for getting which one is the lower one, which one is, sometimes it's clear, sometimes it's not, right? So this arrow says first thing that I have had, or the first thing which is the lower limit, is going to be my parabola, which is x squared.
Squared.
And then the top line is going to be the upper limit, which was y equals to x. So this is the limits of integration for what we have had as inner one, or the second term, okay, so the dy. And then it was just really clear by that little arrow, it's just starting from here and ending to this part, okay? So this is what it is. And then what was the integrand, or the only surface that we have had here?
X squared plus y squared.
And that's it, okay? So then I don't think we have, as you see, for the integration and limits of integral, and everything was just really doable in both ways, huh? So I'm going to leave it the integration here, and then try the other type too, and then to see, this is just really same step, same. It's not one of them difficult, the other one easy. No, it's just really the same thing, okay? So what was the type 2? You have to start with the y, or the numbers for the y goes first. What is the smallest value of the y that you see?
Also 0.
Mm-hmm. So you starting from 0 and you finishing by all the way to the
4.
So this is from 0 to 4 for this one. And then the inner one, which is the dx, or the next 10, which is for the dx. So what do you hit from the left side? So if you start from the left side,
you hit 2x first,
and then
your x squared after.
Can I put the 2x over here and then x squared next? The problem is I'm writing for the x. It has to be in terms of the y. So it's not y in terms of x, because it's writing for limits of x, it has to be half of the y. Does it make sense?
Okay. Yeah, you have to flip it around and do it in the other terms. Solve for x. Okay.
That's half of the y. And same thing for the other one. If I just erase what I've done over here, so it was originally y equals x squared, but it has to be x equals plus minus. But I know I'm in positive piece, right? So you know this is a positive piece of the y. So then you can just, sorry, positive piece of the x. So you need to just write the positive one, okay? So is that fine? This is the limits of integration. Now I need to think, no, I don't like to work with the square root, right? So I prefer to go with type 1, right? Because when I plug in, I will have some square roots. It's not just really tough for any type of techniques. It's still use of situation, but it's just maybe better to go with type 1. Make sense?
Yeah, for type 2, do you always start with the y, with the y, or rather your dy, you always start with y when it comes to the type 2?
Mm-hmm.
Okay.
Mm-hmm. Again, if you have any question, I don't know where I see my participant. Oh, it's here. I have 12 of you. Any question, guys? Do you want to add anything? No?
I'm okay.
Okay. Move on.
Yeah, we can move on.
Okay. So for the, what is it? For the integration, if you let me just skip the integration, is really straightforward. I don't want to do the integration. And this is a fancy graph, and that's just the integration. And that's the number, and it's just what we have done in this the other type, and that's the limits. So everything is just really with the detail right there. Okay. But the main thing, as I said, for 80% is really writing the limits of integration. Graph it first and then write the limits of integration. Okay. So move on to the example number 3. And that says,
I have a quick question, Professor.
yes.
Would you ask on a test to do a type 1 or a type 2, or could we kind of choose which one we would like to do?
No, usually no. It's just really whatever you prefer to do.
Okay.
Okay. But there are some problems in your practice tests that ask you to practice both ways. But at the end, we do whatever is easier to do.
Okay, thank you.
Okay. I mean, just really remember the integration is not that much hard as long as I don't have any problem with the graphing, okay? So if you don't have any problem with the graphing, you should be fine here. It's just quick chapter to just put the information of our calculus 1 and then here graphing from calculus 3. So next example is really same idea. There are 2 graphs given to us. You need to know how to graph from the algebra classes. One of them is paraboloid, the other one is parabola, the other one is just a line. And then the same thing, you just keep going and graph the get the intersection and then graph it. But just to remind you, we have had something from the algebra if you don't remember. So for example, if you have had this is your parabola in a standard form, and then the vertex, if I need to find out in this, is going to be minus b divided by 2a. So then the y value is going to be when you plug in minus b divided by 2a. So this is going to be either upward or downward parabola. But if you have the other way, which is going to be x in terms of the y, and this is going to be, for now, the y is minus b divided by 2a. So then the x is, when you plug in, I'm going to call it g to be different, the b divided by 2a. So just an example for this one, which is in terms of the y. So the example is just something from algebra. I'm just reminding you something from the algebra. It seems it's not in a standard. I try to make it in a standard. So that gives you y squared minus 6 equals 2x. So that gives you actually x is half of y squared. Am I right? If you divide everything by half, if you divide everything by 2, so half of y squared and then minus 3, okay? So that tells me the a is going to be half, the b is going to be 0, and the c is going to be negative 3. So this means if I'm just looking for the vertex, because that's really the way that we have learned how to start for graphing parabola. So I have to say minus b0, okay? So it doesn't matter what is the rest, huh? Minus b divided by, that's just really y value to be 0, and then x value equals, when you plug in y to be 0 right over here, so that is just really negative 3 left, okay? So this is really negative 3 left. So that's just the point of the vertex, okay? So this is fine, that gives you 1 point. And then if I get the intersection, then I can just get the other point. So this part that I'm trying to explain is reminding you so many things from the algebra, first of all, and then I can just get the limits of integration, right? So the next step is to see the graph, I need the intersections. So that gives me, how do I plug in y squared is x minus 1 to the second equals 2x plus 6. Am I right? My intersection? Is it fine? So I have to plug in from here to here, right? So then I have x minus 1 to the second, a little bit algebra to simplify to get the answer, x squared minus 2x plus 1 this side, 2x with the other side plus 6. So that gives you x squared minus 2x minus 2x, that gives you 4x. And then plus 1 minus 6 is minus 5. So then if I just factor it out, the product is negative 5. The addition is 4. So this is negative, this is plus. So the intersection x equals negative 1 and x equals plus 5. And then the y value, if I just plug in either here or here, it's fine. So your y value is negative 2. And then your y value, if you plug in 5 minus 1 is 4. Okay. So then you have really enough points to have all of your graph, right? So you have one over here, and then 1 over here, and then 1 over here. So you have 3 points of your graph, and we know is the left-right parabola. And then it seems I need the negative piece, x equals negative 1. So, and then x equals negative 3. So I just try to have enough room for both of them, positive and negative. So this is 1, 2, 3 for the vertex. This is 1, 2, 3, 4, 5 for that point. So the 5 goes 1, 2, 3, 4 up. This is going to be here, and then negative 3 is here, and then negative 1, and then I have 1, 2, negative 1, and negative 2. It's just here, okay? So if I want to make a graph of the parabola, so this is going to be nicely in this direction, huh? Okay. And the other line, which has negative 1. Okay, so remember this is a negative 1, which is your y-intercept. It passes this point, it passes this point too. So that was the intersection point, right? So this is the intersection point, this is the intersection point. So then the other line is just really going this way. Okay, so that was algebra. So I don't think we have any problem with graphing such this thing. And this is just really keeping every single step, and that's the region of integration. Okay. Should I give you time to do something? What are you doing? Is it fine for you as of now?
Just, yeah.
We are fine, huh? So because you're listening, this is just, what is it? Y equals 2x plus 6. Okay. Can you tell me which way do you prefer to do? Type 1 or type 2? Hmm? Type 1 or type 2? No idea.
Type 2 maybe, as in type 1 gonna give us square root again for the x.
Okay, so let's say if you want to try type 2, yep. So let's say you have to set the y first, right? So what is the smallest value of the y that you have right over here? And what is the biggest value of the y that you have right over here?
-3 and 5.
That was -2, sorry. Y, right?
The biggest y, -2 and 4.
Yeah, so let me just highlight it one more time. I'm here, right? And then I go all the way to here, right? So this is what the y is. So if you just consider to be a constant, I have to make it depend, okay? So then this is going to be the dy, and then what's the dx? So you have to make that arrow thing to know which one is left, which one is right. So we have started from the left and then all the way to the right, huh? So left to the right. So left is going to be that thing, but make sure it's in terms of the x, huh? I have made it in terms of x, so I'm going to use it right over here. You see, this is this is in terms of x, is 1/2 of y squared minus 3. And then the line in terms of the x, no, I didn't make, right? So the line in terms of x is going to be y plus 1, okay? So it's y plus 1. And then is there anything to integrate? Is there anything to integrate? Is right over here, right? So your integration was originally y squared plus x, okay? Make sense? Any comment for me?
Could you repeat that one more time for the bounds with x in terms of y?
Yes. As we see, let me just select, okay, so as we see, this blue one is going to be left one. The blue one is just the one that has this equation. And if I solve it for the x, that's just the result, right? Mm-hmm. Okay. And then if I keep going, the last line that I hit is going to be the line of y equals x minus 1, which if I solve it for the x, you have to move this -1 at the other side, then that should be here.
Oh, okay. Okay, I see it.
Makes sense. Any other question?
Yeah, got it.
Can I do it in type 1? Does it make sense to do it in type 1? For this, I will say it's just really different. I'm going to use the graph of the slide right over here to just explain what is in type 1, because otherwise I need to really make another graph, okay? So we don't want to have a messy graph, okay? If you look at here, and your plan is to make it type 1, huh? So means you must start with the x as constant, okay? When you start with the x as constant, it seems you have started from here, the minimum value, and then your maximum value is here, right? So it's all the way from here to here, so which is -1 to the 5. But your problem is your y's are not the same. So when you are moving from here, so you have started both from the curve of the whatever is parabola is to the other parabola piece. But when you move to this piece, is different. You hit the line first, and then you hit the curve of parabola, or y squared equals to x minus 6 next, okay? So which place that is changing? So this is still line, this is still line to the curve, this is still line to the curve. So you see right over here is the place that is changing, okay? So if I make the line of x equals, sorry, my line wasn't really nice, so let me just redo the line again. Okay, so if I make this line of whatever is the intersection, which was x equals -1, so it seems this is just really two different regions. One is right over here, which is different limits of integration, and the other one is right over here, which is different limits of integration, okay? So we have to make it in two pieces if we do it in type 1, okay? I'm going to practice it because that's just something that we need to learn. So for the blue highlighted region, I have to start from the -1 is the smallest value. Sorry, that was a different number. What's this value? What is this value? Oh, that was -3. Okay, yeah. So the vertex was -3. You see, we found it over here. So the vertex was a -3. So this is the smallest value. And then you go all the way to here to the -1. So when you are from -3 to -1, and then when you are from the -1 to the 5. So these are different. The limits for the y will be different. The limits for the y will be different, okay? So for the first one, which is the blue one, okay, so you have started from here and you end with this one for the y values. What is this line? What is this line? Originally was supposed to be y squared equals 2x plus 6.
Yes.
And then if you square root both sides, is going to be plus minus of this value. The lower limit is negative, the upper limit is positive. So one more time, the parabola always has two pieces. One is negative, which is in below the x-axis. This is positive because it's above the x-axis, right? Make sense? So again, we don't like this way, but we are practicing because we need to see the limits of integration, however they are, okay? So one more time, for this yellow piece, which is right over here, for this yellow, which is right over here, your lower limit and upper limit, both of them are just really your parabola. But we maybe haven't seen the parabola in this one to be positive, negative, because we are always looking to the one curve. But now we need to look at, because it's just really two different pieces coming from here to the here, and then that's just from negative to positive. Does it make sense? And then for the green one, if I have started from here, which is my, what is it, negative one all the way to here, and I'm going to change it green, okay? So this is just going to be the x, right? From negative 1 all the way to the 5. Negative 1 all the way to the 5, okay? So this is negative 1, and then this is a 5. We are done with that piece. And then as you see, the green arrows shows you started with the line, and then you all of these green shaded part, your lower limit is just your line in terms of y was x minus 1. And then your upper limit is always your curve or your parabola. And in terms of the y was 2x plus 6 is a positive, right? So this is still positive part of your parabola because it's above the x-axis. So that is going to be your integrand. And again, we don't like this way. Is a long way because we have to make it to two pieces. Does it make sense?
Yeah, it looks not nice.
Any other question? Any question for this one? And it's there, okay? So all of these details is just written nicely there, and then integration is there. And the same thing that we have done, okay? So same thing that we have done is right over here. So all details is typed there so that I explain over there. I don't know what time is it now. Okay, so I have one more example to move on to the new section. So let's just make a short break and then do this problem. Oh, sorry, two more examples. So let's just make a short break. The short break is just really stop teaching, but you can ask your questions if you have any. If you want to just take some water somewhere, restroom, you're fine.
How long does it break?
7 minutes.
Okay.
I don't have any time here to say 7 minutes. Okay, so yeah, we will come back now. It's 12:06. 7 minutes is about 13. So we will start at 12:15.
And we're going to go back over example number 4.
Yeah. So we'll do first example number 4, and then we have example number 5 too. Okay. I need a person for the class of section 7 to be representative, which means just to inform me if I forgot to change anything, like just the assignment due day, if I forgot to change anything like group work due days. Okay, so you are really one student with one class, 2 classes, or 10 classes. I am really one teacher with 5 classes or about 150 students. So I don't want to mess up with the dates. I try to be right organized as I was in the entire semester, just to email you whatever is the due days, and I will do always. But if someone can help me, so for example, I got an email from Nora that I forgot to just extend the due date for homeworks because we didn't cover chapter 12. So if just really one person, one email would be really more clear for me than really 10 students just saying the same thing. Okay, why you didn't extend it, why you didn't extend it, because I just really forgot. Sorry, that's just the only reason.
I can keep doing it. I'll keep an eye for all the dates.
Okay, so Nora, if you accept that one, is including every due dates. Okay, so your responsibility is just make sure the email that I send is really correct dates.
Okay.
And then is really covering what I'm asking you to do. So if I don't teach you, I don't expect you to learn, right?
I think that makes it pretty straightforward.
Yeah. Can I ask a question about the exit ticket?
Mm-hmm. Oh, we have nice exit tickets. Somebody was complaining about everything. Yeah, that was great. I mean, it's just really talking about those type of complaining is really great. So ask please right now.
It wasn't quite clear to me why there needed to be 2 of each group. Was it because people don't participate?
Oh yeah, that's a good question. Okay, so remember, because these are really at the end of semester, you will wish for such a exit ticket. So that's just the first thing because you don't have time to go back and see what you have learned or what you haven't learned or what you have had something difficulty to understand or just whatever it is. Okay.
Yeah.
So this, you will wish for these exit tickets because that's just really like whatever you do just when you review your homework, when you review for the final, so you can quickly go back and see, okay, so that was a problem. Let me check. Do I know or do I remember those things from 10 weeks ago to 12 weeks ago? And then since it's really same course, same class, same schedule, your exit ticket is shared with the other class. So you have group number 1 to 12, they have group 1 to 12. Okay, so if I ask you to do for example, exit ticket number 4 is going to be for 3 groups of 1 to 3. So it's just one from 1 to 3, group number 1 to 3 from section 7 and group 1 to 3 from section 10.
Oh, our group left 2 comments for everything, but it's all good.
That's still good. Yeah. Okay. So don't again did you understand what's the main purpose?
Right. Yeah.
For now we are fine. Okay. So for now we are all fine because we are going current just schedule. So I'm teaching you double integration. You are doing your homework on double integration. But for final, because it's just including everything from the first day, we don't have time to review everything. Okay, so these are just really helping you to remember what it is. Let me just open what was that complaint things, which I can solve some of them. Some of them I can solve it, for some of them I cannot, right? So for example, because the complaining guy, have you read that one or not yet?
Yes.
I read it. It was great.
Yeah, it's just really something, right? But if you need just for the extension due dates, that's the complaining doesn't help you, right? So you need to request. So request is better than complaining. So for example, he was asking, we didn't have time to practice group work number 7, but the good thing is on group work number 7 you didn't have to use 11.8. You could do it with the previous, and there was just really 3 questions, 3 nice questions. what I wish really you, because now we have learned how to use the Zoom, and Peter actually just asking, can we just do the group work through the Zoom? I think you can. Why not? Because you have access to the Zoom as I have. You can make a meeting. You don't have to meet each other. So you can make a meeting. Actually, you must make a meeting with your group and then discuss about if you add more problems. So that's great. So you don't have to do only your own problem through the Zoom. So Zoom still is just the best place to discuss with your classmates too. I know you have social media. I know you will have many other options to meet with your friends when you are sitting at home. But I think now we are learning the Zoom. Zoom is just really great part. You can share your your tablet, laptop, or paper, so however you are doing. And as long as you have your phone on your hand, you are good. I mean, you don't need that much devices. I need the extra iPad because I'm teaching. Otherwise, all the device that you need to connect to your friends and do something is just really your phone on your hand, because it does have the Wi-Fi, it does have the camera, and then that's it. You can talk through your phone. And I will suggest the Zoom, because that's just really, now we see it has nice features. And again, if you have any problem with the assignments, I have extended the assignment. I don't think even 11.7 and 8 is due by the next day, and you have had really plenty of time to finish it. What was the complaining thing? It was just about the not time to finish it, huh? Was it anything special for that complaint if you have read it? It seems everything is about, it was just simply, could be one request, can we have extension on 11.7 and 11.8 instead of this much complaining? It was just really simply say, we need more time for 11.7 and 11.8 because there was no time to finish it. And actually I did that extension. I don't think it was just really, I think it's due this week. Am I right?
Was the group work for group work 9 also due this week on Thursday? I thought I saw that 8 and 9 were due this week, but
I don't think so.
Group work 9 is next week.
Again,
okay.
remember, Noura, because you're responsible for this type of thing.
No, group work 9 is not due this week. It's exit ticket 9 and group work 8 this week.
So because
Okay,
I'm
good.
just really doing week by week, right? So you can't trust those things anymore because we are just doing week by week. For now, we have had, actually we can do with 2 weeks, hopefully, okay? When you typing, I can't read it. Okay, sorry.
Okay.
Unless I go back over
the thing
here.
was that last week the group work was fragmented into it being due on Tuesday and being due on Thursday. The amount of problems we had to do didn't change. It's just the due dates for the group work, which I think the complaining guy has a problem with, because like maybe they do their homework later in the week and don't have time to do it earlier in the week.
For last week, actually by week number 8, we've been all in the same schedule. We haven't had any problems, so we have to do just all the problems exactly the same order. And then the problem started from the end of the last week, and that's just really the first week that we are in this system. And then the original plan, yes, exactly, the original plan was because these chapters are based on, somebody is typing on my iPad, my laptop, sorry, but that's fine. That's fine, we can erase it later. Yeah, you can, I left that one, or just I can disable you to write on my screen, but I think that's a good feature. We can use it whenever you want to point which problem you have any, or which line you have any question. So you can use your pen or pencil, your hand, to show me which part is your problem. So again, the original plan, if we haven't had this problem, was to have 2 group works each week for the 3 weeks. Why? Because these are so much practical. I mean, it's not really something that is like a tangent plane equation, give you one equation and you just get the gradient vector and plug in, that's it, okay? So for chapter 12 is just really practicing, 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 and practicing. For every single problem is different than the other problem. There is nothing that I can say, I have tried 10 problems, so I can do the number 11, okay? So since chapter 12 is too much practical, means without practicing, you can't do anything. I have had from the last, I will say 16 years, I have had 2 group works for each of these sections, okay? So that's why it was just really packed. It was really packed. So it was 7 and 8 for one of them, and then 8 and 9 for the other one, and then 9 and 10 for the other one. It was just really packed. But since we get to the slowdown and then we don't have just any meeting, so it just really spread for a few weeks. But that was really the original plan. You're supposed to have 2 group work each week for this chapter 12. And you have passed one of them, which was 6, 7. And then originally 8 and 7, 8 and 9 was together, 10 to 11 was together, and then I just had to just make it more expand. So you are right, is a lot of them, but remember, as I said, this is just really different, okay? So this type of integration, I know what you're supposed to know. I'm just making the group work all in purpose to give you enough skills for different problems. It's just really giving you some skills that you need for different problems. So for example, group number 8 is just only for 12.1 and 12.2. Group work, sorry, number 8 that you're supposed to do is really based on 12.1 and 8, which is the double integration. And then group work number 9 is only for 12.3. And that gives you really nice skills to practice, plus your homework. And then group work number 10 is just only 12.5. So it's just really giving every single group work in purpose. And it was originally 2 of them each week, but now we can't because we need to slow down. But for the homework, I have extended. I really extend all the homework from last week.
So I have a question about one of the problems on the group work, number 8. The problem was specifically asking about switching the order of integration.
Yeah, that's what I want to do right now. Yeah.
Okay. I was just asking, like, all it asks is this for us to rewrite that equation as a reverse, not actually solving through the problem, because I didn't actually see a function for us to plug in.
Yes, exactly. Yeah,
okay,
that's
good.
what you're supposed to do. Do you know? Okay, now it's clean. So let's go back to the lecture. This is the problem that it asks you to find the volume. As you see, the information or the planes equation are really 1, 2, 3, 4. So this is 4 of them. And can I do this problem without 3-dimensional graph? I think you can. It's possible to do it, but it's just helping you to make the 3-dimensional graph. So I don't have any problem with the plane of z equals 0 because I have learned that's just really the same as xy plane. So xy plane is right there. You don't need to graph xy plane, right? So xy plane is right here. So that's just the base of your graph. And same thing for this one, which is your x equals 0 or yz plane. So then I don't need to remember how to graph them because yz plane is just really right on the graph. So this is your yz plane, which is right over here. Okay. And then for x equals to y, yes, I don't need to remember how to graph this plane because this is the line of what is it? X equals to y. And then when you stretch it in z, because it's missing the z, so this is z is missing. So when z is missing, you have to just make your graph stretching in the z direction. So that's why it's making this one right here. And that's just the middle one or the slant one. So it's just right there. And the only thing that we need to know from this what is it, course is just how to graph the plane equation, okay? So for me to make a step-by-step of this graph, I'll start from the beginning, and then I will graph as I have done for many of the classes. So I'll just say, how do I graph x plus 2y plus z equals 2? So then this is x, this is y, this is z. So you have to get your x-intercept, y-intercept, z-intercept. So x-intercept is 2. X-intercept is 1, 2. And then y-intercept is, what is it? If I plug in x to be 0, z to be 0, y-intercept is 1. And then z-intercept is 2, 2, right? So this is just really reminding you step by step what we have learned in previous chapters, okay? So I'm going to make my graph a little bit bigger. So then let me just call this one to be 1 unit and this one to be 2 units. So let's just make this one to be 1 unit. Okay, so this is the point of x-intercept, this is the point of y-intercept. So then this is to be 2 units. So this is the point of the z-intercept. So that is going to be a little bit bigger to see. Okay, so that's my plane that I have learned previous chapter how to graph it. And then again, for the plane of coordinate planes, I mean for this plane and this plane, I don't have to worry about, or I don't need to graph them, which is just z equals 0 right over here, and then a YZ plane. So YZ plane is right there. Okay, so that's just okay. I don't need to graph it. The other thing that I need to graph is just x equals to y. For x equals to y, so you have, if you plug in x to be 1, the y is half. So if plug in y equals 1, so x equals 2y, the point of 0, 0 is 1 point. And if I plug in y to be 1, x is 2. If I plug in y to be 1, x is 2. Okay, so this is point of 2 in x direction, 1. So that's just the line right there. Okay, but you need to stretch it in z direction. So this is just make it more parallel lines. I think this line is not that much parallel. Let me make it parallel line. This is better. Okay, so then the other, this is the line of x equals 2y, and then that's just really when the cutting is just, we are cutting the graph right there. Okay, and I think this intersection is important to us. This intersection is important to us because you have the line of x equals to y, and then from here, because the z value is 0, you have x plus 2y equals 2. If you want to know what's that intersection, is really intersection of 2 lines, right? So you have x equals to y, and then you have the plane equation, which is x plus 2y without the z value. So z value, to make it 0, that gives you this point. And that's how we can get this intersection. So it's going to be x plus plug in 2y plus, and then 2y equals 2. So that gives you 4y equals 2. So y equals 2 divided by 4, or 1/2. So that's the point. The y value is 1/2. And then the x value, if I plug in back, is going to be 1. Okay. So if I want to make a 2-dimensional graph of exactly right over here, or for my graph, if I make it more clear, I'm just trying to write this triangle, which is again x equals 2 and x equals 2 and y equals 1. So x equals 2, y equals 1. That was this line. And then the intersection was 1.5. 1.5. So that was the intersection. So the other line of x plus 2y equals 2. If I plug in x equals 0, y is 1. If I plug in x equals 0, y is 1. So it's one intersection. If I plug in y equals 0, x is 2. Another intersection. So that gives me this line. This is x plus 2y equals 2. This is x equals 2y. And that thing which I'm looking for is y-axis is right there. This is right there. This is right there. That's just the limits of integration. That was 1. That was 1. Okay. The main thing that I need is two-dimensional graph for now. So I need to see what are these lines and what's the intersections. Okay. Can I do it in type 1 or type 2? Type 1 or type 2?
I would say you have to do it in type 1 because if you go from a type 2, the left to right rule doesn't seem to work. Type 2?
So type 1? No,
I was
it
going
could
to
be
say
either.
type.
Okay, type 1.
I would say type 1 might be easier.
Any other idea? Type 1 means you have to set the limits of integration in x first, right? So means what's the smallest value of the x to the biggest value of x, which is 0 to 1. And then dy is going to be, let me change the color. So moving from here to the here. So first line to the last line. So it has to be y as a function of x. Remember, this is the limits of y. So half x. And then the upper limit, I don't know what it is, right? So you have to keep the 2y, move the x at the other side. You have to solve it for y. And then this is 1 minus 1 half x. And then what is the integrand? Anyone knows what's the integrand? What should we integrate over?
Is it x plus 2y plus z is equal to 2? Don't we solve that for z?
Exactly. So you need to solve it for z. So the function has to be as a function of xy, right? So this is going to be 2 minus x minus 2y, right? So whatever is in terms of z is going to be your integrand when you solve for z. So it's 2 minus x minus 2y. Fine?
Could you explain one more time the integrand in the middle?
Integrand, huh? Not the limits of integration.
Yes.
Okay, so remember when you are doing the, one more time, if I just write it down somewhere here. Okay, so if you have to get the volume of something, so you have to say double integration of a surface, right? So that surface is a function of xy. Okay, so what is given over here, it's not solved or is not a function of xy. So then you have to write down your only surface that you have as a function of z, or a solved for the z. So that means you keep it the z one side and move everything in the other side. Okay, so this is the exactly what the plane equation is.
Okay.
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 And one more thing that you can think about always, if it was a solid, this is a top surface, or this is the roof of your surface. So your integrand is always whatever is your top.
Okay, thank you.
Okay, so as you see over here, it's mentioning or reminding you, you must have two graphs, because one of them gives you your integrand. So it says make this two different diagrams. One of them is the three-dimensional. Okay, so the three-dimensional gives you always the integrand. So what I supposed to integrate, right? So this is your integrand. So to find the integrand, I need the three-dimensional graph. And then the two-dimensional graph is just to find my limits of integration. Okay. So this is the same thing, and that solve the problem, and that's just really same problem. I want to just explain example number 5 exactly, because you need it in group work number 8. Okay, and this is a typical problem from this section. This is very typical problem from this section. Sometimes it asks you to evaluate, sometimes it asks you to change the order of integration. Okay, so change the order of integration, and this means if it is dy dx, make it dx dy. Okay, what's the reason I need to change the order of integration? So this is the main point. Original function is e to the y squared, and it has to be integration, or it has to be dy version. Okay, so I have learned in calculus 1, this is going to be u, but the problem is I do not have what is my du in this integrand, huh? So the problem is, it says evaluate, it didn't say the change the order of integration, but it is really impossible to do in this way. So that is impossible to do, because I don't have this one. If I had 2y, I could do it, but I don't have, right? So the way it is impossible to do. So then I have to reorder the order of integration to integrate it, right? So this is non-integrable function. It will be possible if I just really make it the other way, make it in terms of x, then this is a constant, I can easily integrate it. Does it make sense? Yes?
Sure.
Okay.
Yeah.
So then, so how do I reorder the order of integration? Because as you saw, the type 1, type 2 might be really different, right? So one of them was really one single area, and the other one was divided to 2 pieces. So it's really different to go from one to the other. So then I have to make sure I have first the graph nicely in just really with the units. Okay, so this just has to be a really nice graphs. Okay, so when I look at to this one, I just say, okay, so the limits of integration for the x has to be between 0 to 1. Limits of integration for the y has to be between x to the 1, okay? So then where I am, I can just make the graph to be x and y, and that's just really something that I need to know. The inner one is really the main graph, okay? I need to know if I graph y equals x and y equals 1, which is the limits of integration, y equals x is right there, and y equals 1 is right there. So this is just the main thing that I need to know. Whatever is inner one is building the graph, basically. So as you see, that matches with the x2. So x is going to be, if I just highlight this piece, x is going to be from 0 to 1, x is going to be from 0 to 1, and y must be from x to the 1. Again, it's not really integration from 0 to 1, integration from x to 1 of e to the y squared dy dx, same as, is not the same as you just say, I have to switch it, I will, that's just it, right? So we have seen many examples with which we tried it in just make it in type 1 and type 2, and you've seen how it's different, okay? It's not really changing this limits in this way works. Actually, this is really a false integration, because this is a false integration because you can't start with the variable. You must start with the constant. So the only way that you can just change the order of integration is first graph it. So if you graph it, you will see what would be the limits of integration, right? So first you have to graph to see what's the limits of integration in different type. I don't know, this is going to be type 1. Now I'm going to change it to the type 2. Okay, so please do not reorder directly right in this problem, right? So that's a false thing. So you have to make the graph and see what happens if you just go to the other way. So if I go to the type 2, which is just really make this problem possible and easy, you have to start with the y, which you started from 0 all the way to the 1. That's just lower limit and upper limit. And then you have the dx, which is going to be from the left to the right. So left is just the y-axis is 0, right is just in terms of x, y. Is that fine? Any question for this one? No? Fine? So that's it. So you integrate in terms of the x, that's is just really completely a constant. So in terms of x is just really x. So then you plug in the value of 0 and y, and then integrate in terms of the y. So which is really nice, because in this case, that is really what I was looking for to do the u substitution. Now I have it, right? So now if I call u to be y squared, then du is going to be 2y dy, and then I just need to make it half, right? So this is going to be, I'll do integration right over here. So it's just e to the y squared half. So because we don't want to change the limits, so directly make your integration and u substitution and plug in back the u to be y squared, and then plug in the values. This is it. This is the answer. Any question here? Is there any question here?
I have a question for the limits on the integral for dy. Could you do from 0 to 1 instead of 0 to y?
Can you point where you are talking about? Because the limits of the green one, the
Yeah,
limits of the
so once you change it to change the variables.
So these are for
Yeah.
These are for x's. All of them are for x's, and the y's are from 0 to 1.
Right. No, I meant for the x's.
Okay, so for the x,
Yeah,
can we make
could
it from 0 to 1?
yeah.
Okay, so remember, if you make just what is it, y's from 0 to 1 and x's from 0 to 1, so then you will cover this thing, then it will
Okay,
be
I
a
see, I
square,
see. Right,
right?
right,
Which is not true.
right.
Okay,
Okay, got it.
any other question? I think last time I remind this slide was in the previous slide too, I mean the previous section too, just to remind us whatever rules that we have had in calculus 1, it works nicely over here. So integration of addition is addition of integration, so means you can split it out if you need it, or you can just put it in the same way, so that's just really fine. If you have any scalar, you can factor the scalar out, so that's just really what we have done in calculus 1, and we factor always the constant out. If you have any inequality, you can integrate both sides of the inequality, and it doesn't change the sign of your inequality. So it stays exactly the same way. This was last time. Addition to that thing, we have tried actually some examples that we have to split it out the region. It says if your region is splitting out to do 2 pieces, it's fine. Do the first piece separately, do the second piece separately, and then add the result. That gives you the entire one. So that if I can just come back to the example, I meant really the one that was just the parabola one, right? So this one, that's what it says, and we have tried it over here. So is just really 2 different pieces right over here, and then we can just do it first, take care of the number 1, and then when we have done, you go to the number 2, and addition is going to be the same thing that you have tried in the previous one. Okay, so if you need to split it out, it's fine. The answer is going to be the same. As many as pieces, it doesn't have to be 2 pieces, it can be more pieces. Okay. So if I can remind you what you have learned in calculus 1, let's see how many minutes do I have. So if I can remind you what you have learned in calculus 1, your calculus 1, when you were trying to get the just the area between 2 curves, so you have had, for example, y equals f of x given to you, and then g of x was the other function that was given to you. So when you get the area between 2 in calculus 1, finding the area between 2 curves was integration from intersections of these 2 curves from a to b, and then top minus bottom, right? So you have had always integration of the top curve, which is g of x, minus the integration of the bottom curve, which is f of x dx, okay? So this is just when you were in calculus 1 to get the area between 2 curves. There, we didn't know what is the double integration. It was perfect. Now I want to say that's exactly the same thing that you do in double integration, okay? So if you're supposed to set the limits of integration of this thing here in calculus 3, you just say, okay, I have decided to do this one in, let me make this one bigger. I have decided to do this one in type 1. So this is just the limits for the x, and then limits for the y. So means moving. Here is the upper, lower limit. This is the upper limit. So you go from the down to the up. So that gives you the f of x to the g of x. And then I don't need to have any integrand. So is this two the same?
Yes.
Because when you integrate of the 1, is going to be y plug-in upper limit minus lower limit is the same thing, okay? So that's what it says over here. So in order to find the area by double integration, you shouldn't have any integrand. In order to find the volume by double integration, you must have a function of 2 variables inside, okay? So you do the area without the integrand, so which is just really what we have learned in calculus 1, and you do the volume with the roof, with something on top, okay? One thing that we have it over here, is, this is not really that much common for this course that you need to know, but it's just in a case in future courses, if you knew a function has bounded. So what does it mean? So I can just say cosine is an example, right? Cosine is a function that is bounded. Means I always know it's just bigger than -1 is smaller than 1. Okay, so it does have the upper limit and lower limit for the values of your function. Or I know the sine is just a bounded function. If you know what is upper limit and lower limit of your function, so means this inequality, means this is going to be bounded one. So this is bounded from here to here. So for sine and cosine is really between 1 and -1. So the rule says if you wish, you can integrate all sides. Okay, so you can integrate all sides of these inequalities all the way. So this is going to be integration of this piece, integration of this piece, integration of this piece. So that's really saying the same thing. You can integrate all sides, okay? So that's just not to solving integration, it's basically to estimating the value of the integration, right? So this is just really basically estimating the value of integration. So it doesn't help us to get the solution. It doesn't help us to get the solution, but it does just really get the estimate for the values, huh? This is just a simple example. Your problems, because you don't know that much bounded function except the sine and cosine. So this is just really a simple example to say, I don't know how to solve this double integration, right? So this is just really something, if I call this one to be u, wow, the du is really long. I can't just get the product rule and then it's a long one, okay? So that's why it says not really solving, estimating, okay? So I just say the sine is bounded between -1 and 1. The cosine is bounded between -1 and 1. What does it mean? If I multiply sine and cosine, so this is y, is going to be exactly same bound region, okay? Since the problem asks me to do e to this power, I can e all sides. You can e all sides of your inequality, right? So this is e to the -1, this is e to the sine x cosine y, and then this is e to the first. And then the property says it's fine to integrate double integral, double integral, double integral, everything over the given region. Okay, so since this is a constant, I can factor it out. Then I left with the double integration. I meant to change the color. So I left with the double integration of dA, and then this is double integration of what my question asked me to estimate. And then this is e factor out because that's the constant, and then double integration of number of 1. So that was e, sorry. And then that was integration of dA, okay? So this is dA. So that's just area. We have learned this is just really area. Area of what is written over here? Area of a disk with the radius of 2. Area of disk with the radius of 2 is going to be pi r square, or pi 2 to the second, or 4 pi. Okay, so e to the -1, 4 pi is the area of the disk. That's just really estimating the value. Okay, and that's it. Do I know the answer? No, I don't know. I just estimated. It should be a value between these two numbers, and I don't know what's the exact value. So then our, I will say, skill or problems here is really limited to this type of function, which we already know what's the max and min of those. Okay. I am going to stop here. So main thing that we can do right now, do you have any question? Do you have any question? Is there any question? If I can find
no.
how to stop recording and stop recording. Huh?